Welcome to the second video that talks about mapping ER designs to relational models. So I'm going to consider 4 different relationship types here and discuss how each of those might be mapped to a relational model. So to keep these ER designs simple, I'm just showing the attributes, and there's an assumption that every attribute has a primary key called ID. Now it doesn't matter if a whole lot of entities have an attribute with the same name. You can obviously distinguish by what entity they're connected to in the ER design. Right, so if we take a look at the first relationship, we've got 2 entities, student and course. Each of those entities corresponds to a relation, and the relation has a primary key ID. Okay, so the mapping between, or the relationship between students and courses. A student can enroll in several courses, and a course typically has many students enrolled. So that's a classic end-to-end relationship, and the standard way of mapping those kinds of relationships is to introduce a new table to represent the relationship itself. So it kind of makes sense to talk about an enrollment relationship, or an enrolls relation. Alright, so what's going to be in the enrolls relation? Well, clearly it has to indicate which course is involved and which students involved. And in the standard end-to-end mapping, you have 2 foreign keys, one for each of the tables involved in the relationship, and the combination of those 2 foreign keys is going to be the primary key for the new relation. Now, a lot of the time here I'm going to be calling things tables. Table, relation, treat them as analogous. So, given what I just said, we're going to have one attribute that refers to the student table, and we're going to have another attribute that refers to the course table, and the combination of those 2 forms a primary key. So in other words, we indicate that student X enrolls in course Y, and we only need to say that once. Now you might say, what happens if they fail course Y and have to repeat it? Well, in fact, the notion of course here actually corresponds to a course offering. So we could be talking about Comp 9311 in semester 1 of 2017. That's really what we mean by course. So if by some unfortunate circumstance a student happened to fail that course, they could repeat the subject, if you like, Comp 9311, by taking the course Comp 9311 in semester 2 of 2017. Alright, so the enrolment table has 2 foreign keys, and we indicate foreign keys by arrows from the foreign key to its corresponding primary key. So the student attribute in the enrolls relation refers to the ID attribute in the student relation, and the course attribute in the enrolls relation corresponds to the ID attribute in the course relation. And once again, foreign key course referring to primary key ID in the course table, and we'd add an arrow to indicate that. Okay, so that's the complete mapping for that relationship. Generally, what we'd find in a situation like this is that there is additional information associated with a relationship, for example, the grade, and potentially other information. Maybe a student gives an evaluation for the course. So that would be the most likely complete representation of the scenario here. So I didn't mention it before, but these things here are meant to represent a bunch of other attributes that I'm not going to specify because they're not interesting in the context of this relationship mapping. Alright, so that's it for the first relationship in roles. Let's take a look at the second one. So now we've got two different relations, or two different entities. In fact, we've only got one. So we've got the staff, who are the conveners of courses. Now, the relationship here has some interesting information. The arrow here tells us that a course has one staff member as their convener, and the fact that there's a thick line on this side tells us that every course must have a convener. On the other hand, on the staff side, a staff member could be a convener of many courses. You know, for example, if you teach the same course in a number of different semesters, and a staff member doesn't have to be a convener of any course, so that's why we've got a regular line there. Okay, so mapping this relationship. Now, because a course is associated with exactly one staff member, we don't need to introduce a new table for that. In fact, we can store the relationship between the course and the staff member simply by adding an extra attribute to the course relation. So let's make some room and put the extra attribute here. And this attribute is going to be a foreign key referring to the staff table to tell us this staff member being referred to is the convener of this course. So let's call the attribute convener. Oops. And that's unfortunately just a little bit too big. Okay. So the convener attribute is the representation of the convener relation. So we haven't had to introduce another relation to represent the relationship, and we can represent the relationship simply by the foreign key primary key connection. So let's add the connection here. The convener is a foreign key referring to primary key in the staff table, and that's the representation of the one-to-n relationship convener. In this diagram, there's no way to indicate this part of the relationship. We simply say, okay, the course has a convener attribute which references the ID. We're not forced to give a value here in the relational model, so that's part of the semantics that isn't quite represented in this model. Alright, so that's the complete representation of that. So let's look at the next one. So now we're talking about a different kind of staff. We're talking about staff members who work in bank branches. So we'll go back to something that looks a little bit more like the base problem. Alright, so this relationship here is a one-to-one relationship. So a staff member can be the manager of one particular branch. So that's what the arrow there is telling us. And a branch can be managed by one staff member. And in fact, the fact that the line on this side is thick means that every branch must be managed by a staff member. So every branch has a manager, and a manager manages one branch is essentially what this diagram tells us. Okay, one-to-one relationship. Now, one-to-one relationships in theory, because we've got branch mapping to a single staff member, and we've got staff mapping to some staff mapping to a single branch, potentially we could put foreign keys in both tables. So we could have the manager or managers attribute in the staff table, which is a foreign key referring to the branch. And we could also have a manager attribute in the branch relation, which is a foreign key referring to the staff relation. We could do that, but what we normally do is we put one of those foreign keys, because once you get to the point of writing SQL queries, it doesn't matter where the foreign key is, you can still do a join to link the two tables. Now, in doing a mapping, we tend to favour using a foreign key which is required to always have a value. If we put a foreign key in the staff table, we can see that some staff, in fact most staff, aren't managers, and so a lot of the time the manager's attribute in the staff table would be null, and that in some sense wastes space in the database. However, if we put a manager attribute into the branch table or branch relation, then because every branch is required to have a manager, this is always going to have a value. So manager, once again, a little bit too long, let's make it a little bit smaller. Okay, so this is sufficient to represent that one-to-one relationship. So all we need to do to finish off the relational model is to put an arrow that indicates that manager is a foreign key into the staff table. Okay, like that. So that's the complete representation, or that's a sufficient representation for the managers relationship. Now notice, in some sense, we've kind of inverted the relationship. Rather than staff managers a branch, the branch has a manager who is a staff member, but that's fine. So having that connection allows us to relate the manager of a branch to a particular staff member, or to work out who the manager of a branch is. So we've got a representation of that relationship. So the final one, we're going back to student and course, and we're going to change the semantics a little bit. In the first example up here, we had that a student can enroll in many courses and a course can be enrolled in by many students, but we didn't require that a student had to enroll in any course. Now, if you've got a student who hasn't enrolled in anything, you could argue that they're not really much of a student, and so we might want to insist that a student is enrolled in at least something. And so that's what we've done in this final relationship here. So we've said a student must be enrolled in at least one course. We're still allowing a course to have no students because maybe we enter the course into the university database and nobody has yet enrolled. So we have to allow for that scenario. So we're going to end up in the same situation as we had before. We'll introduce a new table. It's still an end-to-end relationship. So we have to introduce a new relation to represent that. Once again, we'll call it enrolls. And as before, it has two foreign keys that form the primary key for the table. So we've got the student, and we've got the course that they're enrolled in, and we've got potentially some other information associated with the enrollment, such as the mark. And as before, these two attributes here are foreign keys into the corresponding tables. Whoa. And we want to put an arrow here to try a bit harder. That's it. And we have an arrow connecting the student attribute in the enrolls table to the primary key in the student table or the student relation. So adding an arrow. So that's the mapping that we had before, in fact. Now you might be wondering, how can we represent this? Is there something we can add to this model here that'll capture that semantics, that little piece of information about the problem? And it turns out that there isn't. Given an N-to-M relationship, there's no way in the relational model to capture the notion that one or other of the entities must be involved in the relationship. So that's as good as you can do for that final relationship here. So that completes the mapping of all four of those relationships, and as I said, you'll see in some worked examples later on of how to map these things into SQL data definition language. Okay, that's it.